Hello friends, myself Agrawal AS, Assistant Professor in Civil Engineering Department. Today's topic is calculation of distribution factor in moment distribution method. Now, some standard values are with us regarding the relative stiffness and the distribution factor. Now, the relative stiffness of a member at a joint whose far end is fixed, that is equal to the I by L. The relative stiffness of a member at a joint whose far end is hinged or simply supported, that is equal to 3I by 4L. Now, the distribution factor of a joint at a member, that is equal to relative stiffness of the member to the total relative stiffness at the joint. Now, some standard values with us. Distribution factor for a fixed joint is 0. Now, how fixed joint? Like this. So, if the end support is a fix, in that case, the distribution factor is the 0. Now, distribution factor of a simply supported or hinged support at a joint is 1. If the end support is simply supported or hinged, in that case the distribution factor is the 1. Means how this like, suppose this is the simply supported end, so in that case, or this is the hinge support, in that case the distribution factor is the 1. So no need of the calculations. And the last one is the what? Distribution factor for overhang support. So inner side distribution factor is 1 and outer side distribution factor is the 0. Now how this overhang? Like this. So here what? If this overhang is here like this, in that case inner side always the distribution factor is 1 and at outer side always the distribution factor is the 0. So this standard value 3 with us, that when the fixed end, the end support is a fixed, df is the 0. When the end support is the simply supported or hinge, the df is the 1. And in case of the overhang, inner side always is 1, outer side always is the 0. Now, we take this example here. Now this beam ABC, here this end is a simply supported end and this end is a fixed end. So no need of calculation of distribution factor for the joint A and for the joint C. So here in the case only we have to calculate the distribution factor for the internal support. So what internal support is? Only the joint B. So this is the table. Joint, which joint is B. Then member. So always start the member first letter that same as that of the joint. If the joint is the B, so letter starting is the B and look towards the A. What here? The always, if the joint is B, so starting point of the member letter is the B and look towards the A. So what here? If B, look towards this A. What? This A is what? This is the far end. This is called as the far end. So in that case, if the far end is fixed, we have seen that relative stiffness, that is equal to I by L. So what here? I is equal to 2I. So put here 2I, L is equal to 4. So that is equal to 0.5I. Now again from the joint B, so if you are taking the joint B, so starting letter should be the B. Now look toward the C. So what is a C? C is a roller support or simply supported. So when the far end, this end is now what is a far end. So when the far end is hinged, in that case relative stiffness is the 3I by 4L. So here that is equal to 3 into, put here I is equal to the 3I. So here 3I, 4 into L is equal to 6. So that is equal to 0.375I. Here what? Far end is hinged, that is why here 3I by 4L. Now here total stiffness is what? The all the stiffness of the member which are meeting at the joint. So here at the joint B, so BA and BC is member meeting. So this is the sum of this 0.5I plus 0.375I. So that total is equal to 0.875I. Now we have already seen the definition of this distribution factor, that is what? A relative stiffness of the individual member to the total stiffness at the joint. So total stiffness at the joint is what? 0.875. So we keep it here, and here 0.5I is the relative stiffness of the individual member. So ratio of this, that is equal to the distribution factor 0.57, and here is put this 0.375I here, K divided by the sigma K, so that is equal to 0.43. And one more thing, always at the joint, the distribution summation of the distribution factor is always the 1. So now, what here? Distribution factor of a joint is, fixed joint is 0, so here is 0. Again what? Distribution factor for simply supported or hinge support joint is the 1, so here is a 1. And now we have to only calculate the joint B. So here is for BA is 0.57 and for BC is the 0.45. Now next problem. Here is what? This A and C both end are the fixed. So no need of the calculation of the distribution factor for the joint C and for the joint A. Only we have to calculate the distribution factor for the joint B. Now this is the table. First column is the joint, member, relative stiffness, total stiffness and distribution factor. So joint is B, so here joint is B. So always in the case of the member, the starting letter should be the joint. So joint is what? B. So starting letter should be the B and look towards the A. What? B to A. So A is what? A is becomes the far end. So far end is fixed. In that case here, the relative stiffness is this is I by L. So put the value of I here 2I, L is equal to 4. So we will get here 0.5I. In the same way, here what? B to C. So C is also the far end. So here what? Relative stiffness is I by L. So that is equal to 4I by 6. Here I is equal to what? Is a 4I. That is why here kept the 4I. So that is equal to 0.67I. Here is what? Far end is fixed. Now total stiffness is here at the joint B. So these two members are meeting. So summation of this two member. So here summation of this 0.5I plus 0.67I, that is equal to 1.7I. Now distribution factor, what is the formula? The stiffness of relative stiffness of individual member divided by the total stiffness, in the same way that we have calculated in the previous one. Here is K divided by the sigma K. So K is equal to 0.5Y, this 0.5Y divided by this total stiffness 1.7I, that is equal to 0.42, and here is 0.58. So previously I told you that the summation of the distribution factor at any joint is always the 1. Here is 0.42 and this is the 0.58. So summation is the 1. So now here is what? Distribution factor for fixed joint, that we know is 0, and for this is 0, and we have calculated the this 0.42 and 0.58 for the joint B. Now next example here. Now here is a 3 span. So beam is AB, BC and CD. The span is 4 meter, 3 meter and 6 meter. Here is a 2I, I and the 4I. Now this is the table here. for the here. Now, no need of the calculation of distribution factor the joint A because of the fix we know is 0. No need of calculation the distribution factor for the joint D because that is for the 0. So what here? Always we have to calculate the distribution factor for the inner support because outer support we have the standard value. Now, what here joint B and here is a joint C. So joint B, so B to A. So B to A. What here? This A end is a far end. So what here? So I by L, that is equal to, put here I is equal to Y divided by the 4, that becomes 0.5Y. Then B to C. So here what should we consider? This is a hinge or simply, so if the internal support is there, one more support is there. If we are considering B to C and one more support is there, so treat this support always as a fixed support because we know this support have the moment. So if the support have the moment, it means this we treat as a fix. So that is why here BC is taken as far end as a considering as a fix. So here put I is equal to I and N is equal to 3. So this becomes 0.33I. Now here, so summation of this at the member B is BA and BC. So summation of this both this relative stiffness and this becomes 0.83 as per our calculations. And same calculations here that K by sigma K. So this becomes 0.6 here and 0.4 here. Now the joint C. So at the joint C, which are the members? C to B and C to D. What we have previously told you, always starting point the C. If the joint is C, so our first letter should be the C. C to B and C to D. Now C to B. So B end, look towards the B end. What here? B end, this B end. Now here, one more support is there here again. That is why treat this support as a fixed support and apply the relative stiffness of the far end is fixed. Apply here the relative stiffness far end is fixed. That is why here the relative stiffness is the I by L. Now we are putting the I is equal to I here because here I and the L is equal to 3. Then C to D. So look towards the D. So D is your far end. D is your far end. Always the second letter is the far end. Here B to A is a far end. B to C, C is a far end. C to B, B is a far end. And D, C to D, D is a far end. So far end is a fix that we know. The stiffness is the I by L. So put all this value here, 4I by 6. So we got the 0.67I. So summation of both these is a 1. So put this value here, individual stiffness divided by the total stiffness, the distribution factor 0.33 here and the 0.67 here. Now here what distribution of factor of fixed joint is 0. We know this is 0, this is a fixed 0 and internal B and C that we have calculated in the previous table. So these are some standard, that is distribution factor of simply supported or hinge support joint is the 1 and distribution factor for overhang support inner side is 1 and outer side is 0. Now this is the example where is the overhang here. Now at the C is the overhang C to D. So here what we know, standard value for the fixed end A is 0 and for the overhang we know inner side is 1 and outer side is 0. So we have to calculate only for the what? Inner support. Always we have to calculate the distribution factor for the inner support. What is here? The joint B. So the joint B is here. Member is B to A and B to C. So B to A. So A, B is the near end and A is the far end. So far end is what? Is a fix. So that is why is I by L. And here B to C. C is what? This is the what? It's a simply supported. Though there is overhang, this is a simply supported or roller support. So this is the relative stiffness as 3I by 4L. So always when the far end is simply supported, roller support or overhang support, always the relative stiffness is the 3I by 4L. Far end is what means? Far end means second letter is the far end. So put here the 3I, I is equal to here is I, divided by the L is 4 into the 3. So this becomes the 0.75 summation, and here is a K divided by the sigma K. So that is equal to 0.67 here and 0.33 here. Now distribution factor of a fixed joint is 0, that we know. That is why we kept here the 0. Then here simply supported end. Now this is the overhang. What here? The standard value is what? Distribution factor for overhang joint. What? Inner side is 1. So this is the inner side. So here is a 1 and outer side is the 0. So outer side is the 0. And this 0.63 and 0.33 that we have calculated. Thank you.